Hi friends, welcome to our channel. Let's have a look at a recently appeared problem, maximum coin collection. So in this video, we're going to explain how to address this problem by dynamic programming. So our plan is the following. We are going to give two versions of solutions. We are going to write the first version with full explanation, and then we are going to translate the first version to the second version. So here I'm not going to read through the problem statement, but it's crucial to understand the requirements. So here one point I want to mention is that so the switches here is at most 2, right? So that's basically constrains the number of switches between the two lanes, lane 1 and lane 2. So we want to return the maximum number of coins Mario can earn after performing at most 2 lane switches. So here are 3 examples. So you can see the outputs and the explanations. Meanwhile, not 3, it's actually 5 examples. So the constraints on the length. So the length can be as long as 10 to the power 5. So in other words, we need to pay attention to time complexity when we do the coding. So notice that there can be positive numbers and negative numbers within the lane. So with that said, we are ready to explain the first version of solutions. So here, let me first get the length of this lane. Because lane 1 and lane 2 have the same length, so this will be sufficient for us. Then actually we can follow the switches, right? So we can do 0 switch, we can do 1 switch, and we can do 2 switches. So switch 0. So this will be, let's write float negative infinity times n, right? So basically this will record at each position. If we do 0 switch, the maximum coin we can collect. So basically it's like you stay in the first lane always, in the first lane always. So then the second one, switch 1, so 1 switch. So also we can do float infinity times n. So here basically you do 1 switch because you start from lane 1, then you do switch, you're going to stay in the second lane. Switch to lane 2 and stay in lane 2, right? But here there's a problem when to switch, right? So that's important to trace. Then the third one is that we do 2 switch, so let's float in negative infinity times n. So here is basically you originally at 1, and at some point you switch to 2, and then you might stay in lane 2 for some time, then you switch back to lane 1, and then you stay in lane 1 finally. So that's the initialization. Let's call it DP initialization. So next, what we want to do is to fill out these 3 DP list. So actually, if you make them together, it forms a 2-dimensional list, right? So here we need to consider the current index. So basically, we want, if we set the DPI, so how do we set a DPI plus 1? So here DP can be switch 0, switch 1, switch 2, right? So now let me use this for current next in collections. So it's pairwise. So basically the range n. So this means this. So basically we have this pair 0, 1, 1, 2, and then up to n minus 2, n minus 1. So you can write it like this, or you can just use start from set 0 and then start from 1. So this is just for some convenience, nothing special. So now basically we can, because at the very beginning current will be 0, next will be 1, right? So we want to set the switch next, right? So here, so we can do. I guess I forgot to set the first at index 0. So at index 0, so if you stay at 0, so you get a switch 0 at 0. This row should be the len1 and 0, right? So then if you do switch 1 0, so then you switch to len2. So basically you are going to have len2 0, right? So switch 2, actually we do not need to set it because it starts from the first to len2 and then switch back to 1. So we can make it infinity, negative infinity. So then the result originally will be the max of switch 0 and 0 and switch 1 and 0. Right. So in between, we are going to set the switch for at the next index. So and also we are going to update this result variable. Now let's look at switch 0. So at next. So basically we want to get the maximum con we can collect ending at this index, but we do no switch. So in other words, we just stay in len1. So in this case, we just get the, so either we just use the current con, so that is len1 at next at the current position, or if the previous steps have collect cons that is positive, we can add it, right? So switch 0 next -1, actually it's current, right? So that is current, and then plus len1 at the next position. So actually it's good to call it current and the previous. So I'm going to use this interpretation. Next correspond to current. And this current will correspond to previous index or current -1. So that might be better for the interpretation. So this line is keep in len1. So this is the one. So next is going to switch 1. So in other words, arriving at the current position, we did one switch, right? So we're going to do the max. So first, because you are in to one switch, you can only like this, right? So you're going to stay at len2, so it's the current position. And then for this, actually there are two possibilities you arrive at this position. So one is that previously you didn't do any switch, so switch 0 and current position, and then you add len2 next. In other words, we do the switch at this next position. And another one is you have already done the switch, that is switch 1 and current, right? And then you so this is the, you can understand as current -1, or right? So then this will be len2 next, right? So that's the second one. So next we can look at switch 2 at this position next. So this, if you do two switches, you are going to ending at len1, right? So you have len1 at the position next, and then so because you did this switch, so you can do this switch 2. You have already done two switches, right, in the press, and then you do the switch here, and or you can do a switch 1 current, and then add len1 at the position. So this is the third one, right? Switch at current position. So you adding this len1 and the previous collected cons by 2 switch, or you add the len1 current position and then add the cons collected previously done 1 switch, and then the second switch is done from len2 to len1 at this position. So that's basically all about it. So now what we want to do is to so result will be max the previous result state, and then switch 0 at the current position, and switch 1 at the current position, and switch 2 at the current position, right? So overall, we just need to return the result state. So that's actually a solution format to this problem. Let me first run it. len2, so let's see, this is len21. So I'm going to change this one to be A. Now let's run it. Same thing here. Switch 1. Solution. Let's see, index. Switch 1. Let's see, where's the problem? So switch 1. This is len. So here I should say this is 0. Yeah, it passes all the cases. Notice that due to the way we wrote the code, for each position, like say len1, len2 itself, actually we included all those comparisons, right? So now let's look at the generic case. Yeah, it passes all the cases. I guess that's the first version of solutions. So here we are using 3 length list to do the to hold the DP table, and we do initialization and we do DP update. So then we do the comparison, and finally we return the result. So actually a natural question to be asked is that, so what if you change this problem to be that we allow at most k times k switches? So then this way of initialization might be problematic, right? So now let's do the second version. What I'm going to do is to change this version to be a 2D using a 2D dimensional DP table. Let's call this one version v1. Use using 3 length n list. So now for this one, I'm going to use 2D, essentially 2D table. But here I'm going to use not using the specific 2D list. I'm going to use dictionary. So this is actually very convenient. So what I'm going to do is first I will get the length of this len1 or len2, and then I'm going to initialize a DP table like this. Collections default dict. So similarly, like here, I'm going to map everything to be negative infinity, right? And then I'm going to do some initialization. So for this, in parallel to this one, so here the key of the DP table will be index, number of switches, and then to the maximum cons can collect it, right? So now what we do is that we can say DP 0 0. So at index 0 and 0 switch. In other words, we switch, we stay and in len1. So in this case, so this is len1 0. And another one is DP 0 1. Do 1 switch. So we have len2 0. And actually, I don't need to do DP 0 2 because there's no need to do 2 switches, right? So then the result, I'm also going to initialize as a maximum of 0 0 and DP 0 1. So this is very convenient. So next, we are going to do the DP update. So this is also in parallel to the first version. So now let's see for I in range, so 1 to n, right? Then first I want to set DP I0, right? So in other words, if I arrive at this position I, but I keep in len 1, what would be the maximum count I can collect? So one is you collect the len 1 count at this position, or you do this. What's the maximum counts you can collect before this I? In other words, dp I minus 1 with 0 switch, right? And then plus len 1 I. So this is the first one. Stay in the first len. So now let's look at the one switch case. So if you do one switch case, actually you are going to end at len 2. So at the current position, so let's see, you have this one. And then because you are doing one switch, there are two possibilities. So one is that you have already done the switch. So we can do len 2 I, then dp I minus 1 and 0. Then the switch is currently done at the current position. Basically at the index I, you switch from len 0 to len 2. This is the one possibility. Another possibility is that you switch to len 2, but you already did that. So in other words, dp I minus 1. So before this current index, you already done one switch, right? So this means that, let me re-explain these two items so that you get the idea. So this second item means that before the current index I, I didn't do switch. At the index I did a switch. That's why you have I minus 1, 0, right? So the third item is here. Before the current index, in other words, up to index I minus 1, I have already done the switch, but I already in len 2, right? So that's this term. So we need to take the maximum of these three possibilities. So similarly, let's look at this one. So for this one, you can do, because you are going to end at len 1, so you can do this len 1 I. And then, so originally, before this, the one possibility is that before this index, you have already done two switches. Then you are going to do len 1 I. Another possibility is that before index I, you have only done one switches. That is dp I minus 1. That is 1. Then you plus len 1 I, right? And then each time after you do these three updates, you are going to do this. Not return. Result will be the max of the pre-state, then dp I0, dp I1, dp I2, right? And then we do the return of this result. So this way, actually, we finish the second version. So now let me run it. Yeah, it passes the case. So now let's look at the generic case. Yeah, it passes all the test cases. So now actually here in this one, actually I guess I forgot one, len 1. Next. But the solution is still correct, because in switch 0 and in switch 1, we already included len 1 and len 2 together. But if you add this here, for sure it is still right. Let me first check that one, and let me check that one. Yeah, so I'll change this one to be version v1, and then let's check this one. Yeah, both works. So actually these two formats correspond to identical codes. However, the formats of coding or the representation of coding can be important. One direct thing is that here, when you do this, you can write it in a for loop, and this is the one comment. Another comment is that here in this problem, we require at most 2 switches. If we generate this question, how about, like, say we can allow k switches, then the writing should be in this format. You cannot just say switch 1, switch 2, 0, 1, 2, up to key minus 1. Because if key is changing, it's hard to initialize. And this way, actually, it actually bring us some convenience. So overall, both the two formats of the code is not very long, right? We just encode the problem requirement in the coding and then run it. So with that said, I guess that's about it for the current video and the current problem. If you would like to support this channel and also find this useful, you are welcome to share with your colleagues, classmates, and friends. So there are a lot of, so far actually, it's more than 900 videos. It covers a lot of LeetCode problems. So with that said, I guess that's it. Thank you.